Okay, so 3, 2, 1, go.
Hi there. I will try to entertain you today with two scenarios. For all of you who have experience running production systems and being on call for them, this will bring back memories. For everybody else, I hope it will jibe with you as well. So, scenario A. It's 4 p.m. on a Friday afternoon and you're ready to close down your laptop and just go home. And suddenly you hear that customers are complaining that your system is not working and they cannot use the service. So you have a look and you see that there are some alerts for your dependency and they don't tell you anything, you don't know the dependency, they are not very informative. You're trying to figure out what's going on. In the meantime, customers are taking to Twitter to complain that they cannot use the system. Folks who are actually responsible for the dependency, your friendly team, nobody is at work anymore. Executives are demanding to know what's going on and when will it be back up. You cannot focus on anything. Everybody is talking over everybody else. And you know that the longest Friday night is ahead of you. How do you feel about it? Because my hands are already shaking and I'm stressed and it's not fun. Imagine scenario B. You get an alert that your dependency is not doing very well. You look at the alert and there's something meaningful explaining that the error rate is going up. You also have a link to a runbook that tells you, if this happens, do A, B, C, D. You try those things. They don't work, that's okay. You know where to go to click a couple of buttons and suddenly there's somebody who comes in, takes care of charge of telling the customers that we know about the issues and that we're working on it. Telling executives that there is an issue, they need to be on standby in case we need them to do a business decision that engineers cannot make. There's somebody who pings people from the team that's responsible for dependency so they come up online or come back to work and take care of it. You work this through, you solve the issue, after which you sit down, do incident review, figure out what needs to be improved in the architecture, in the operations, so this never happens again, and it never happens again. Scenario A, scenario B. What are the differences? Team A was hoping that things will be all right. Team B thought there will be a problem, so let's prepare for it. Because hope is not a strategy, and I really advise you to have a calm Friday afternoon or 2 a.m. any day. Be prepared. Prepare things like your incident response plans to deal with situations whenever they occur. Prepare tooling. Have runbooks that actually tell you what to do. Do on-call trainings before you put people on on-call. Anybody here on-call anytime? Few people, hands. I know that you've been riding with the laptop on the bicycle, so I know that. Yeah, you have memories. All of those things can be prepared ahead of time, so you can work calmly instead of freaking out at some point and everybody shouting over everybody. That's the message I have for you today. My name is Daria. I have been working in site reliability engineering field for a while now. For those of you who don't know it, we take care of running production services reliably. I love nerding out about incident response and on-calls. I'm that weird person. I also really like making friends. Some of you know that maybe already. If you feel like sharing your stories of those bicycle rides with laptops or telling me, I've seen this, something worked, something didn't work, I would love to hear from you. I'm super interested in how other people solve those problems. And I will be at the after party. Let's chat. Thank you all.
Okay, so now Dennis is connecting. He will talk about the backlog, the hidden queue, and then there will be quantum computing by Konrad. So, let's go with another lightning talk. So let's start. Go.
Okay, let's have a small experiment. On the right side, we have a single worker synchronous server power. I'm sorry, I got stressed. On the right side, we have a Flask application with one endpoint, and this endpoint we have sleep time 1 second to simulate some work. And we run this application in Unicorn, in one worker, in synchronous mode. And on the left side, we have a client to connect to this server. And we make 5 simultaneous requests to this server. So let's cover it with traces and see what happens. And in traces, we have, in green color, we have spans that related to client side, and in yellow, we have spans that are related to the server side. And, well, as we expect for a single-threaded synchronous worker, we have in yellow requests processed one by one, and each request took 1 second to be completed, right? Right. But this is why it's important to have external metrics, because we cannot trust measurements done in our middlewares, and we need to see from client's perspective. And from client's perspective, we see that our request took 2, 3, 4, and even 5 seconds to complete, right? So where do those requests spend their time waiting to be processed? In the socket backlog. And backlog is a setting that defines maximum number of those pending connections that we can have to our server. And we have this setting defined for Unicorn, we have this setting defined for Unicorn, and this is because these settings exist on a very low level. We have this setting for listen, functions that define to listen for a socket connection in C standard library, and this function used somewhere in our CPython implementation. But what if we set this backlog to 0? So for my particular example, we can see something like this. Requests are processed randomly, and the whole thing takes like more time to complete. But we expected some requests to fail because they shouldn't connect to the socket, right? Because we have backlog set at 0. This is because actually in TCP implementation, we have internal retries that in this particular case saved me from observing any errors in my traces. So until you are 100% sure that you know what you are doing, it's better to keep the default value for the backlog, and this backlog is actually the hidden queue of your HTTP server. And in this QR code, you can find on all the related links to this Lightning talk. Thank you. This is it.
And we are starting. 3, 2, 1, go.
Hi, my name is Konrad Gawda, and I would like to tell you about quantum computers in 5 minutes. So quantum computers have immense power, but also some great limitations. And the whole thing is that it's based on quantum science, quantum physics, that is beyond our intuition. We humans understand how things work until it gets to quantum level. It's just, you see the maths behind it, but it's not intuitive, and it must be like that. I tried explaining quantum computers once to my friend, and after that he said, okay, so in fact those are just analog computers. And analog computers, it's something that history knows for a long time. So instead of bits, which have zeros and one, they're different physical things were the carriers of information. Like, for example, a rope that was going through pulleys and so on. And the analog computers have this value that they don't store 0 or 1, they store continuous. Each register or different carrier of information stores a continuous, so one would say infinite amount of information. If analog computers were even digital, this one is from museum in Warsaw. Okay, coming back to quantum computers, they're based on 2 physical phenomena. One of them is called superposition. So this is something you know about the Schrödinger's cat, and in fact, Mr. Schrödinger invented this analogy to show how absurd is the idea of superposition. So in fact, don't think about it like about this cat, which is alive or dead, 2 states. Physicians like to show it on a sphere like that, but think about superposition like a probability. So in fact, if normal register stores 0 or 1, quantum register stores a probability from 0% to 100%, you may say. So it's a continuous value. So if you have 4 registers, quantum registers, each of them is like a slider. But that's one thing. The second thing is entanglement. So you may remember Einstein's quote that this is a spooky action at a distance. And in fact, it meshes up the probability, and if you have 4 registers, you end up with 2 power to 4 different probabilities. So it goes quite fast, big enough. You can have a different variable, let's say analog variable, for each atom in the universe if you only have 256 quantum registers. So that's immense power. But with this power comes not only responsibility, but also great limitations. So it's like saying having a superhero in a bottle, that you have a very small bottleneck to get to this information. Or like you're the best guitarist, but on a bass guitar. The limitation is that you need to use this kind of gates, which are in fact something like assembler operations. So where is Python in that? There are many Python frameworks to do quantum computation, and in fact they're used just to put operations on the quantum registers. So it's like using Python in a declarative way. So we have 1 minute left. So I will just briefly explain you the most difficult quantum algorithm. Just kidding, I will not. But that's an example of algorithm, how they look. And the world is now working on that. We're progressing. This may have very great power. Why I'm telling you that? Because in September there'll be a conference in Bilbao, Open Source Summit conference, and I just got accepted for that conference with a talk on quantum computers, and it got official. It was announced yesterday. So yeah, you can see me on the agenda. Thank you very much.
So let's start.
Great. My name is Tomasz Krasowski. I'm an employee of Ørsted, and in Ørsted we believe that entire world can run on green energy. But let's talk about Python right now. So we will be talking mostly about plus equals operator, and I'll start with an easy example of adding a number to a number. And can you guess what will be the result of this operation? Not 7, but 2. So close, but not really. So let's move on to a list. If we'll add a list to another list, what will be the result? Extended list. So we'll have a list with the 1 element that we have added in the previous line. Let's move on to a tuple. So we have an empty tuple here. Maybe let's get like 1 element, and let's add a different tuple to this one. The result will be, as you can guess, that we'll have a 2 elements tuple. So this isn't like really complicated. This isn't like a buggy thing of a Python, but there's very interesting behavior when we try to modify a list inside of tuple. So let's create a tuple with a list, and let's try to modify the first element of a tuple. Tuples are immutable, as you can probably know, and we'll try to add a list with like 1 element to the list that is under the 0 index. And can you guess what will be the result of this? Yep, it will be an exception, but with like nasty side effect. Okay, so we got an exception, right? Someone said that it's gonna be added to the list, and you are right. As you can see here, I have created an empty list. I have modified the 0 like element of a tuple, but still, I got the list extended inside the tuple, even though I got the exception like just before. So that can be a little bit unexpected. I wouldn't say that's like a very common issue. I would say that you probably like never ever met that kind of behavior, but we can see why does that happen. So in Python, in CPython implementation, we have a this module which allows you to disassemble the code of a CPython implementation. So let's create this again. Let's modify the tuple. Yep, I see that. Plus equals 1. So we have the same like behavior as previously. And we can disassemble this function, and we'll see some bytecode of CPython implementation. So these instructions are related to the second line, so creation of a tuple and a list. And the third, like the instructions here are related to the third line, so adding the list to a 0th element of the tuple. There are some like things related to modifying the stack, loading variables, and so on. But let's focus on this like 18th instruction, in place add. So this basically extends the list that we have created with the new list that we have created. We have tried to add it to the element of a tuple, and then in this like 22 line, we use a store subscription instruction, which will try to modify the tuple. And this is exactly where the exception will be raised, because we cannot modify a tuple. We cannot modify an element of a tuple. So we have extended the list, and the exception was raised here. So the list was modified like under the hood. We got an exception, but still like the unexpected behavior happened. We of course can like easily avoid that with just using append to the like element of a tuple, or we can use extend to extend it like a list. Yep. So that's like the whole thing. I think like you can easily just avoid this issue, and this is basically based on a book, Fluent Python, and I recommend that you read that book.
Let's start.
Hi, I'm Camila, and I'm working in Orsted with a small kreska above O. Okay, and today I will present you my talk, and I named the key message of my talk to give what you want to receive. And you see the green colors, so I encourage you to pay attention to that green colors later on in the presentation. And regarding the key message, the communication theory says that we actually we don't hear what is said, but we hear what we want to hear. So I can just assume that many of you who listen or read this topic have thought something else. So I'm here to tell you my understanding of that key message. Okay, so first point is that the understanding is the key. You can see the green word give. I cannot give anyone value if I don't understand the person, if I don't understand the person's needs, and if I don't understand my audience. So I assume that on the mind level, of course, and if that would be the key to everything, then probably we would all be there giving and receiving what we want to receive. But why we are not there? What is the problem? What could be the problem? Some of you might know the blind and the elephant story. I hope for some of you that would be the aha moment, thinking, oh, now I know why I don't really understand that guy or that girl, or why they bother me so much, because they think differently and they understand differently, and they perceive the reality differently than you. One might say, looking at the elephant from their perspective, that this is a snake related to the python. That's it in my talk related to the python. One might think it's a wall, and one might think it's a rope. But yeah, of course, everyone has their own truth. But it's definitely an important piece of information. All the pieces are important pieces of the whole truth. Okay, and now, do you have a space to agree to not agree? And now the choice is yours. And the next green word, want to, exactly. If you want to, if you choose to agree to not agree, to have a space for different perspectives. Given that we are different, we have different biologies, we have different backgrounds, we have different culture, we have different education, we have different preferences. Some of us are more task-focused, some of us are more people-focused, some of us are more inspirational-focused, some of us are more detailed-focused. You can choose if you want to hear others. And just for your reference, I found understanding or meaning of the, or difference, what is the difference between hear and listen. Listen is just to hear the sound, like some of you might be hearing my voice, but some of you might also perceive that sound and process that sound in some way. Okay, and I wish you would choose to see the whole elephant. It can be a challenge to give up on forcing others to convince about your own right. The question is that, can you collaborate with people different than you? And the last word, green word, receive. Receive the goal. Okay, but do you know what is your goal? Assuming for a while that you have all money, what would you want to do? And I found great examples of receiving the goals. Thanks.
Okay, you are ready, so let's start.
So my name is Piotr, and as you can see, I like triggering people and choosing controversial topic to like explore kind of like status quo, because we are using Python, but yeah, probably you like also use different languages, and you notice the difference that if you use the C or C++, it's like way faster, but it's also way faster to, way harder to write any code in C and C++. And don't get me wrong, I also like love Python. I use it in my daily job, so I just like to explore the topic and see if we should. And I would like to trigger you to think about other aspects when you write a code, like the energy usage, and for example, if the Python is like the best choice. And yeah, so we all love data, so let's look at the data. And the good news is that the Python is not the worst, because we have Lua and Perl, but the problem is that they are not that popular as Python, so we have problem, because like, as we can see, Python is like 40 times slower than C, C++, and our Rust that was mentioned a lot. So what we can do about this? Okay, if like the energy argument doesn't speak to you, so let's consider like your favorite game written in the Python. So unless you are not a fan of slideshow, then you probably don't like game which has like 5 FPS. So that's why games are written in C and C++. So consider the aspect of like comfort of using the software, because we all love when the software is like very responsive and fast. So why we should like write this in Python and let our user of our software suffer like long time of loading, or in terms of game, like they will like just feel pain playing in 5 FPS. So as the data speaks, like Python is not the best choice. I mean, yeah, we need to also consider different factors, like barrier of like entry for Python is very low, and it's like super fast to write a line of code in Python comparing to C++. So we can consider the human factor, that programmer will consume more energy writing in C or C++ than Python. But I think it's still like this factor is not speaking for Python, because it's still 40 times. So you can do the math and it still be speaking for the C and C++ or Rust to use it, or Java in some cases. But okay, so what we can do about this? So as you can see, I would like you to consider like the energy factor next time you will like choosing the main language for your project, and maybe try to use like some compiled language, and maybe just you can replace small part of your programs with faster languages, like some crucial parts where the heavy computation is done. And yeah, that's my final words. Let's maybe consider some Rust.
Start.
Yeah. Okay.
Yeah.
Hello, everyone at PyCon. My name is Alexander, and I'm a fellow software engineer with Python. And I would like to talk a bit about tech leads and experience that we've been having. So I intended to make it a confession, but it will be a little bit different format. But yeah, I did those mistakes I will be talking about. But first, I would like to answer a question: what after all is a tech lead? Because different people have different view over the this position, and essentially all of them are right. But in my perspective, the tech lead is a hybrid of a software engineer and a manager, because essentially they were software engineers before, and now they start to manage people, to talk with people. And the reason why I chose this exact picture is that technical leader has as much power as they have responsibility, and that's why it is so important to not make mistakes that I did. Because, for example, it is very easy to fall into the power that you get, because essentially when you get a title of tech lead, you get also the authority. Essentially, you can overforce any decision that is being made by your team members. And why it is bad? Because people will leave because of that one day. Aside from that, when you get this title, at some point of time, you start believing this title yourself, and it can also affect your judgment, making you think that your solutions and ideas are much better than any of that your team members can offer. And even if you overcome these challenges, there is another one that was mentioned earlier yesterday on the last presentation. It's the meetingitis. Credit comes to Łukasz Mach. Yeah, it's not my calendar, but it looked like mostly like that. It was even worse. Sometimes I had 3 meetings at the same time. And it's painful, because you have lots of processes you need to manage inside the team. You have one-on-ones. And also you got to talk to managers much more. It gives you power, but it is a responsibility of yours also to manage it. And, 'Cause, 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 The solution I found for myself, and I think it can be useful for lots of people as well, is awareness. You should be aware that technical leadership it is like a role that it opens lots of the doors, but you have to choose them carefully and do your work as well as you can do well, not also burning yourself out by doing wrong things. Because, yeah, I have experienced this burnout, and that's why I am a former tech lead. This is essentially what I wanted to say. Thank you for the opportunity to talk to you. Thank you, the organizers, for organizing PyCon. Also, I'm kind of open for work, so yeah. Yeah.
You still have 1 minute.
I actually did it much faster. Yeah, in case if you are looking for like a senior lead or whatever title engineer with Python, I will be happy to talk to you. Thank you. And yeah, never forget your laptop to the conference.
Hello, my name is Camila. On the first day of PyCon, me and Sinem, we had the Discord bot workshop, and probably you want to some links, and you have link for GitHub repository for some notes about Notion if you want to do by yourself in your home, and is there LinkedIn for my the link to my LinkedIn account, and what else there's? Oh, and the Discord channel where you can ask about that. Okay. Cześć, mam na imię Kamil Kulik, pracuję w Schneider Electric, no i mam dla was 4 linki. Częstujcie się, nie tak agresywnie. O, dobra. Git. Me llamo Camil. Trabajo en Schneider Electric. Tengo 4 encales. Para ti. Gracias. Hasta luego.
What is happening? I'm scared. Okay, it's, oh, oops.
Alcohol.
It's that all? Okay.
Yeah, thank you.
So are you ready?
Yeah, I'm ready.
Okay, let's start.
All right, hi everybody. My name is Martin. I'm a data scientist at the Danish Business Authority, where we do some fraud detection with machine learning. And I'm here to tell you about a nice little piece of software that we built with a lot of help from a Polish company named DeepSense. So it's Polish software, so I figured it would be fitting to present it here at the PyCon PL. It's open source software, and it's very nice. So what is it? Racetrack. Oh yeah, it's called Racetrack. Well, basically, it's a software framework for deploying code to production. It uses Kubernetes. And right now I would have read what it said there, but it says something like it's an opinionated framework that uses conventions to allow domain experts to create operationally sound workloads. And what that means is this. It means that data scientists like myself, we get to write some code, we get to put in a few simple CLI commands and upload that code to Racetrack via the Racetrack API. Racetrack magically transforms this code into Kubernetes workloads and exposes it to our end users. It says ML model users here, but basically you can reuse Racetrack for anything. And this is very nice because as a data scientist, you don't need to understand anything about Kubernetes, which I don't, and we can spend our time actually doing data science. Racetrack it's quite Python oriented, but you can deploy different kinds of jobs to it. You can deploy Python 3. These are the job types that exist out of the box. You can deploy Go, and basically everything you can wrap in a Docker. I only use this one, because that's all I know. I'm a data scientist. So, how does it work? Well, basically it works, let's see, like this. I write some code, and I look at my code. I make sure that it conforms with the Racetrack conventions. It's opinionated, so I can't mess up too much. I write my code. I make sure there are these methods that you have to use. You have to have a perform method. There are other features that you can have where you have to add other methods. I won't bore you with that. It's all in the documentation. You make sure that it's convenes to this. You choose a job type. I usually choose Python 3. You compose a small YAML file with some configurations. This could be like the job type you want to use, a path for a GitHub repo, some configurations about your Docker or your Kubernetes pods, minimum memory, maximum memory, stuff like that. You push your code to GitHub or GitLab. You write Racetrack deploy, and then Racetrack deploys your code. You get a nice little Swagger interface where you can test out your code. You get your end users get REST endpoints that they can call to contact your model to get the response from that model. And you get Prometheus endpoints, other fancy stuff. And that's basically what Racetrack does. It's all open source, so we encourage you all to give it a try at GitHub/the Racetrack. You can give it a spin, see if it's anything for you. There are open issues, so you can even contribute. I saw that there was one marked with a good starter issue, so there is for anyone who wants to dive into open source, this might be an opportunity. Also, we have 2 other components coming up, something called Catwalk for evaluating machine learned models, and one called Record Keeper for ensuring transparency in the way, traceability in the way we use data. Yeah, just a little advertisement for this lovely open source project. Thank you.
Thank you.
Okay, so stupid business people change their mind decision again and 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 again, and I will not do it for the 5 minutes, don't worry, and again and again and again and again. So I will play a little bit advocate for them today because it's not their fault, and because I was frustrated because they were changing those decisions, and it was affecting my job. Seriously, it was affecting what I was doing. They were interrupting my programming skills and development process. So I used the advice from this book. It is actually 69th advice from this book that every programmer should know. Put the mouse down and step away from the keyboard. Each time you are frustrated, you don't know what to do, how to handle your problem, and you are frustrated really that you cannot move forward, just step away from the keyboard and think, have a rest, and figure out why it is happening. So I was figuring out why it is happening, and I discovered that it is happening because everything in our world is changing constantly. And it's not only decision that we are making, everything is changing. That's why the decision must be changed. So the only thing that we can do about decision being changed is to accept it, at least from the side of the business. From our side, we can do much more. And we were taught during this whole conference how to do that. We need to combine all those things because we need to prepare for the change. And we had a lot of talks about how to prepare for those changes. So, for example, we can start using TDD. It is a technique, and here you have some link for my short description how to start with TDD. And also I had today morning a workshop about that. So TDD helps us a lot. It's not only about code coverage, it's not about that. It's a main benefit, but what also we gain by using TDD is that we reduce number of dependencies. And without a lot of dependencies in our code, in our main core code, we are able to change it easily. We are able to change our decision. We are able to even change the database within a minutes or maybe hours in a bigger project. But also we can change how functionalities are working, and we will not be frustrated by doing so. And if we are using TDD, of course, we need to have a good code architecture. We heard about, for example, a hexagonal architecture during this conference, and it is a really amazing tool for gaining flexibility in our code. What else? We need to refactor and avoid rewriting. There is a really thin line between those two, and it is crucial to do refactor. How to distinguish them? You are doing refactoring when everything is continuously working. If at some point something stops working, then most probably you are starting rewriting, and that's bad because it causes frustrations. How to refactor? You can learn from this book by Martin Fowler about refactoring. He has a really great knowledge about that, and there are a lot of patterns, there are a lot of good examples how to create a good code. How to gain flexibility in our code, how to be prepared for the changes? We need to avoid confusion because tangled mess, wrong naming, and not consistent naming are our big enemies, and this is actually the easiest thing to fix in our code base. Use consistent naming for everything. Of course, we were hearing about CI/CD. This is also crucial. If we are not able to deploy quickly, then we will not be able to deliver the new features to our business. And in this book, the Phoenix project, it is a story about a company that almost failed, that almost bankrupt. They say that you should deploy every day, 10 times at least. And it's not about having a goal, it's about being able to do so. And you can have baby steps on everything because you learn by finishing things. And if you have a lot of baby steps, you learn a lot from that. Oh, thank you.
Yeah. Unfortunately, time is up. And the last lightning talks by Maho. Okay, so let's start.
Hi, I'm Maho, and today I was triggered by one of the presentation, one slide of the presentation, and it was a great presentation, but there is one common thing we shouldn't do, and yeah, and I will show you a scary picture, and please say "ooh" or something like that to emphasize how scary it is. So, ready? Yes, it's a scary picture because if you decode it, it's a link which can steal your money or break into your computer or something like that. But there are things that are not scary at all. For example, something like that, or something like that, if you want to install Node.js, or generally if you want to install something from very trusted source, so they cannot try to execute some malicious code on your computer, then they wouldn't do that. But I think they could. So it's strange that we afraid to scan QR codes. It's okay because it can be dangerous, but we don't afraid to do something like that. So please don't do that, and don't encourage people to do that, and instead please download the code, review it, and if it's okay, if there is no RM, FM / execute it. Thank you.
We have one last lightning talk. After that, we are all going to the social event. Where is it? I will explain. Okay, let's start.
Hi, I'm Łukasz, and I'm easily triggered, as you may have seen. So the thing is, you can always try to find another language that will make everything, that will be a silver bullet, that will, work faster, etc. But maybe before doing that, think about maybe there's another way to make your Python run faster and keep using Python and developing faster. Like, for example, don't write, loops, functions that you don't need to. Maybe use libraries that have implemented all of that already, like, NumPy, SciPy. It's all implemented and really implemented very fast. This was my last slide, actually. But I have other, tabs in my browser. So, for example, you can also, instead of using the regular Python interpreter, you can use PyPy, 5 times speed boost already. You can use Python to add annotations that will, also make Python run faster. You can use Piston, you can use Numba, all of those things. And also a cool story. I'm part of an Arma modding group. Arma is a game. Don't bother looking it up. And I make some tools, libraries, etc. And once I saw this library, config to JSON, which is the fastest and most reliable way to convert mission SQL files. I've also made such a library. And I go down here and I see the comparison with other libraries, and I see, not available, crash. Guess who made this library? Yeah, it's mine. Okay, so I was like, okay, I didn't know about that. I wrote the guy, hey, could you tell me what's wrong with it? Could you give me the input files, etc.? And he said, no, you know what? I don't even have them. I just did this, and I did the GitHub, README file, and was done with it. How much time do I have? Sorry.
2 minutes.
Okay, never mind. So anyway, actually, so what I did, I just sat down, opened the Python manual, and actually, long story short, I beat his Rust program like twice-fold, or maybe even my Python code. I don't have the benchmarks here, sorry, not enough time. But basically, I finally got a pure Python implementation, which works in Python and that you can also compile in Python. And it works 3 times as fast as his, Rust program. So it doesn't matter how the program is fast initially, it's how well you use it. Thank you.
Thank you.